Hey guys, this is the last video in Chapter 1, video over problem solving. And I just kind of want to talk about the logic and kind of the steps that are involved when I solve a problem. And maybe it'll help you kind of get solve some problems in the semester as well. So there's a series of steps that I kind of follow whenever I'm approached with a problem or with a word problem. So with all of these word problems, they can be pretty complicated. And they're tough. I understand that, but by following these 7 steps, you can always at least get in the right direction. So the first step is to identify the question. What is it asking for? What is the answer? What should it be? Should it be volume? Should it be mass? Should it be whatever? And so then I have to evaluate. Okay, what is the units that are involved or that are associated? What are the units that are associated with the answer? And sometimes the answer that it should be isn't always clear, like we'll see at the end, or actually even in the next one. It's not always spelled out for you, but you can deduce what your answer should be. The third step is to set out a list of possible ways to get the answer. Sometimes, a lot of times, there's only one way, but sometimes we'll see that there could be multiple ways to get there. So if you have multiple ways, look at them, see which one's the easiest and the best, and then do that one, perform the calculation, and then go back and check your answer. Always check your answer and do the calculations twice. Always do the calculations twice. I can't tell you how many times I tell students that, but they never do it. So let's look at an example following this kind of outline. So here we have a fairly simple question. We've got we want to know the density of something, but we don't have we don't have the units that we need, and we're kind of not asked for the density. So we've got a sample, and we've got a mass over here. So the units that we're given mass over here, and we're given volume over here. And we're asked, does this sample float on water? And so I know that in order to figure out if it floats or not, I need density. So I look at the question, evaluate the question. This is what I need. I need a density. Okay, the next step is to see what units I need for that, and that is grams per milliliter, or grams per centimeter cubed. But I'm not given that. I'm giving pounds and quarts. So the other things I need, the conversion factors I need, is I need 453.6 grams in a pound, 1.057 quarts to a liter, and I can figure out volume from there. So we have to do these conversions. So we have 453.35 pounds in 1 pound. In 1 pound, there's 453.6 grams. So we can get our mass there. And then we go to the other unit, 0.76 quarts. And I know that there is 1.057 quarts to a liter. And I also know that there's 1,000 milliliters in 1 liter. So there's my conversion factors. I cancel out everything, making sure everything cancels, and I'll get my answer. I can bring up my handy calculator over here. It's a lot like the one that we use. I couldn't find an emulator for the exact one we use, but we can do this. So 453.35 times 453.6 gives me 205,639. So 205,639 grams. And for my volume, same thing, 0.76 divided by 1.057 times 1,000 gives me 719 milliliters. Now I can divide the two and get my answer. So I've got 205,639 divided by 719. I get 286. Apparently, way more dense than anything else on the planet, but there you go. 286. So the big answer here is it greater than 1? And yes, it is. So no, it would not float on water. So kind of a walkthrough for that problem. Now, sometimes problems are longer and they require more steps. So you might have to approach it in a lot of different ways. And so I have a problem coming up that I've used before as a bonus on the first exam, just to kind of show you what I mean as far as solving difficult problems. So let's go down. Okay, so we've got this huge problem. Shampoo factory. We've got some dimensions for a vat, and there's 4 of them, and they fill up to 80% full each day, and it costs 9 cents for 10.5 grams, given a density, and we're given that each bottle costs $8. We want to know how much profit the company makes in a year. Seems really crazy and kind of out there, and I don't even know what to do. Well, approach it one step at a time. Like it says, okay, always do it one step at a time. Approach it logically. Always keep in mind what your answer should be, profit per year, and kind of think through what you need to do to get that. So I've got here a set of what I did to solve this problem. I'll show you guys. I don't know if you can read this. Maybe right there. Okay. So what I did, and I'll just kind of talk my way through it. Here it is, so you can screen cap it if you want and take a look at it. Basically, I took my volumes, or my dimensions, converted them to centimeters, and then found out my volume of a vat, multiplied by 4 to get the volume of all 4 vats, and then I multiplied it by 0.8, because they only fill up to 80% full to get each day. And so that is my volume per day. So that was my first step, is go to volume per day. Then I multiply by 365 to get volume per year. And then I multiply by the density to get, and I make sure to write that down because I'll know I'll need that later. Multiply by the density to get mass per year. And then if I'm given mass per year, I know that it only takes 9 cents for 10.5 grams, and I can get my cost per year. So then I can take my volume, move it over. Remember, I've already calculated volume per year, and then figure out how many bottles I produce per year by dividing by 500, multiply by $8, 7.99, and I get my profit per year. Subtract the profit from the cost, and I get about 76 million. Okay, so you can do that on your own, but I just want to outline. Now, there's several ways to do this. You could figure out how many bottles you produce a day, and your cost each day, and your profit each day. Then multiply by 365. You'll still get around the same answer. We've only got one sig fig on the dimensions of the vat, so it doesn't have to be precise as far as down out to 10 digits or something like that, something crazy like that. But you can see that there's multiple ways of doing it. You can analyze the problem and kind of break it down into chunks. Okay, I've got in the first part, we've got 4 vats, we've got dimensions for vats, and we've got 80% full per day. So I can figure out volume per day, and I know that since I've got the density, I can get grams per day. And if I get mass per day, I've got a conversion factor, 10.55. My conversion factor here is $0.09 for every 10.5 grams. So using that, I can get my cost per day, and then I can multiply that by 365, or I can figure out how many bottles I have. There's just a lot of different ways to approach the problem, but the point is, approach it logically, one step at a time, and it's really not that bad to get the answer. Just don't let it, and this is the big point that I have for students. This problem seems too much, right? It's all over the place. Don't read it, and freak out. Because every student does that at one point. They read a question, they have no idea what to do, so they freak out, and it ends poorly, put it that way. So read it, okay? Realize you don't know the entire process, but go through it one step at a time, and I promise you it's not as bad as it seems. Anyway, I'll see you on the next video for chapter 2.